Our next speaker is an industry veteran, Kevin Wheeler. Kevin Wheeler has more than 17 years of information security, IT, and compliance experience. He is the founder and managing director of Info Defense, an information security services firm that specializes in IT governance, risk, and compliance. Kevin has performed security audits and assessments, as well as network security design, computer incident response, business continuity planning, and IT security training for organizations in the financial services, healthcare, government, and IT services industries. His project and employment portfolio includes organizations such as the United States of Defense, Bank of America, Hewlett-Packard, formerly EDS, Symantec, and the state of Texas. Kevin co-authored IT Auditing, Using Controls to Protect Information Assets, a McGraw-Hill publication. Kevin will be talking to us today about securing industrial control systems. Please join me in welcoming to the stage Kevin Miller.
Thank you. Okay, so I like to walk around quite a bit, so I may just be walking around down there, or maybe I'll try to stay up here. So just a little more about me, and I'll keep this really quick.
It's me. I want to record, so I needed to hit that before you did that.
Hit this.
Yeah, okay, sorry. My bad.
Okay, there we go. So just a little bit more about me. Well, first let's talk about what we're going to talk about today. So first, we're just going to talk very briefly about the emerging threat landscape. I'm sure you've seen a lot of these, presentations, and everybody talks about what's happening, in the wild. But we'll just touch on it a little bit, and I really want to draw the parallel as to what's happening with industrial control systems. In addition to that, we're going to talk just a little bit of an overview of industrial control systems, and then we'll talk about some of the threats to industrial control systems, and I have some cases up here which kind of bring it home a little bit. And then lastly, we'll talk about how do we actually secure those SCADA systems, those industrial control systems. So, okay, I guess that slide about me was out. All right, that's good. So if you look at today's internet threats, we see on a daily basis in the headlines. The other day, in fact, I was surprised. I think it was because it's RSA this week, but there was a whole section in the Wall Street Journal about information security. And that's the first time I've ever seen that before. I always see articles, but now the Wall Street Journal even has sections on information security. It's the number of breaches, the number of incidents, it's growing at a breakneck pace at this point. And here's some very, very old examples. I think we have the TJX breach up here. That was a long time ago. And one of the reasons for that is malware. So if we look at what's happened in the malware space, well, first let's talk about exactly what malware is. Malware is a way of compromising a system using a program. Okay, so it comes in the form of worms and viruses, and if you take the cybersecurity classes, there's all types of different malware. But that said, we're seeing more. The number of malware variants on a daily basis is approaching 70,000 at this point. And what that means is that virus protection is having a hard time. The virus protection vendors are having a hard time keeping up. And this is just an example of the growth, and this is up till 2012. So the hockey stick continues. And malware is one of the bigger issues with industrial control system security as well. In addition to that, it's very, very easy to create malware. You can take an existing malware variant and create another variant from that variant using Zeus or SpyEye. One thing that's I think is pretty, I guess, ingenious, comical to from my perspective. SpyEye, you have the ability to check a box that'll actually uninstall Zeus. There's a competition between these different malware kits, per se, and so they kind of uninstall each other and that type of thing as well. What we're seeing is that the threat motives around information security, they're moving from just monetary to both political and national security threats. Can anybody tell me of a recent politically motivated breach that happened? I'm sorry? Hillard? Oh, Hillary, yes, Hillary. Yeah, somebody had mentioned the Sony breach. Yep, Sony breach as well. Anybody ever heard of a guy named Edward Snowden? Yeah, so there's another political, so we're seeing people trying to make points. But then also there's national security breaches, things that are, around national security. And can anybody name a breach that has recently happened that had national security motives? May not have been a breach on the U.S. Stuxnet. Somebody mentioned Stuxnet. We'll talk more about Stuxnet later. Yep, Stuxnet was a national security breach on the Iranians. So, the problem is that the threat, or one of the issues we run into as security practitioners, is that the threat landscape is kind of a moving target, and those motives really make a difference. So let's talk about industrial control systems, what they are, how they work. And this is, honestly, this was one of my biggest, one of the things that for the past 10 years or so, I've read about how SCADA systems are, very vulnerable. And as a security practitioner, I was like, I need to learn more about that. But I don't work in a factory. I don't work in a plant. I don't work anywhere where SCADA is, and the companies I work with, or at least at the time, now we have some companies that have industrial control systems that are clients, but we didn't have any clients even at that time. So how do you learn about this? What is it exactly? What is it used for? So SCADA systems, or industrial control systems, and SCADA, by the way, is kind of another way of saying industrial control systems. They were created, really, started coming online about 40 years ago. And so it's very, very old technology, or you might say well-established technology. The problem is the industrial control system technology really, the fundamentals have not been updated. So the pictures look better, but the fundamentals haven't been updated. So in a factory, I'll just give you an example. We were talking to a customer yesterday, and they said, we have this wall where we have all these holes where all of the gauges used to be. And now those gauges were replaced by a monitor. And that monitor basically has a SCADA system that it's connected to, so that they can monitor all of the different things like temperatures and pressures and everything that's required in order to, in the plants that they have. And they're used in things like, oil pipelines. They're used in wastewater treatment systems. I'm a director for a flood district, and we use SCADA to see when the flood, what we call sluice gates are up and down, and to control those, and to turn the pumps on and off. So that's how they're used. And here's just an example of a SCADA system, or at least something that you might see on a screen, okay? This is a supervisory screen. And we'll talk about the architecture in just a second. So they're used as you can see in the slide itself, power generation, oil and gas industry, water treatment. Those are some prominent areas where it's used. Energy production, so the power companies, they use SCADA. And even building management. So if this building here probably has SCADA systems that are doing everything from monitoring the HVAC systems to controlling the amount of pressure that comes out of the faucets, and those types of things. One thing that's important to note about SCADA, there's really two functions of SCADA. One of them is to monitor. The other function is as an actuator, okay? So the actuator controls. So as an actuator, what that means is we can turn things on and off or turn things on partially, okay? So for an example, you might turn on a pump, okay? So you flip the switch on a pump and you turn on the pump. Whereas if you're turning on something partially, maybe you open a valve 75% of the way open to allow a certain amount of liquid to come through the valve. And here's just another example of, and this is another screen, a control screen. You can see pumps and water wells are represented on the screen. So anybody, what's the issue here? What happens if a SCADA system gets compromised? You turn things on, turn things off. I'm sorry? So you don't know if the readings are accurate. So how many of y'all are studying information security or have been in the industry for some time? Okay, so about half or more. What are the three elements of the information security triad? CIA, what do they stand for? Confidentiality, integrity, and availability, right? Okay, so when you read the gauges and you're not getting the right reading, that's a breach of integrity. And that's something in the information security industry, we focus so much on confidentiality, but integrity is a big part of it as well. Exactly. Yeah, in Germany. Yeah. So the question was, you know, that in Germany there was a steel manufacturer that was hacked, and millions of dollars worth of equipment was destroyed. You know, in the process of hacking, and that can happen because of the fact that we can control these systems. If you turn a system up to 100%, you know, a furnace up to 100%, it'll burn itself up eventually. And that is the problem. And when we look at, we'll do some dissecting of what happened with Stuxnet, which in my opinion was ingenious, but opened up Pandora's box. But that's very similar. That's what happened. Readings were normal, but centrifuges were blown up, you know, in the process. And it turned out for the world to be a good thing, because now the Iranians are set back by about 18 months on their nuclear program. But, you know, you look at what happens if that happens here in the US, you know, in a water treatment plant. Well, all of a sudden people don't have water to drink. So when we look at the architecture, there is, and actually I got a better slide here. I'm just going to use this slide. There are three components of the architecture, and this is a SCADA architecture. Those screens that we were looking at earlier, they are. I wonder if there's a laser on here. I guess not. Those screens are at the supervisory level. Okay, at the supervisory level, we also have a database typically, or there is a database that always runs. So there's a database, and it's keeping historical information, so you can get reports about levels of whatever you're monitoring. But this is the brains of the system, and the brains. So that's at the supervisory level. At the control level, you have either what's called an RTU or a PLC. PLC stands for Programmable Logic Controller. And RTU is Remote Terminal Unit. And so basically what those systems do is they control sensors and actuators. They are kind of like the hands, you know, versus the brain. There is IP connections. If you look at this diagram, everything in orange is IP. And then once you get to the PLCs or RTUs, the control layer, they control the device layer or devices at the device layer, and those don't run on IP. They run on proprietary SCADA technologies, but usually some type of serial cables or other type of wiring. So if we look at this architecture, where do y'all see, what do you think the problems are? What do we need to protect? Let me just say that. We need to protect the orange part. Okay, so anything that's orange we need to protect. And the reason why is because it's easily accessible. Anything that's IP based, you can access if there's no firewalls or something to prevent you from accessing the IP, the IP node. So we need to protect the PLCs and RTUs at the control layer, and then also at the supervisory layer, we also need to protect the SCADA management systems as well. So let's talk about some of the different types of threats. There are nation-state threats. Recently, and actually I've heard this several times over the past 5 or 10 years, there was a report that came out that basically says that pretty much all of our power distribution systems have already been compromised by the Chinese. The Chinese aren't doing anything right now because they're making a lot of money from the US. But if ever we have a situation where we go to war, similar to the way that, that when Russia went to war with Georgia, they may end up using some of those compromised systems to cause damage to the US. Cyber terrorism is becoming an issue. From the other side of the world, with impunity, a terrorist can log into a compromised system here and cause all kinds of havoc. So everything from disrupting power to disrupting water supplies to stopping wastewater treatment, which would be really bad if that happened. Unfortunately, SCADA, the technology itself, industrial control system technology, as I said earlier, has not really been updated, at least not in a way that makes it more secure. And so it remains inherently insecure. If you have an IP connection to any part of that orange on the architecture, then you can do a lot of damage typically. It is truly one of the biggest issues that we have in our nation from a security perspective. I'd say it's in the top 3, which is one of the reasons why I focused on it. So here's a case study. This is an Illinois water district. Actually, Curran Gardner Water District is out of Illinois. Back in 2008, they had a SCADA system that was compromised. It was basically a Russian hacker, and that person would do what's called bumping the pumps. So turning the pumps on, turning them off, turning them on, turning them off. And that really wasn't noticed, and so burned out some pumps in the process. And so in that case, it was a cyber terrorism. He did it to really cause problems. That was the threat motive. Some of the equipment was destroyed, very similar to what happened in Germany recently. And the reason why was because there was no IDs or passwords. He was able to dial in, I believe it was a dial in if I'm not mistaken. He was able to dial in and he didn't require any authentication. Had access to the system, and just did what he wanted at that point. So what they did was they went ahead and they put IDs and passwords and enhanced their logical access control. Very simple remediation. So here it is in 2011. Anybody have any ideas as to why they would have no passwords on their systems and they'd be just accessible through dial-up? Okay, so what I heard was management thought it was a mechanical process rather than an IT system. Is that right? Okay, that's exactly right. SCADA systems traditionally have not been treated as IT systems. They're treated as industrial systems. The ownership of SCADA systems is industrial control system engineers. The engineers basically control them. They don't want IT to really touch them, from a political perspective. So that's exactly right. And so the problem that you run into is that they don't know anything about security typically. In IT, we do. And so really, in order to fix the problem, we really kind of have to apply information security controls that we use in the IT industry, which can be applied in order to address the issue. It's like any other, you can reduce the risk, you can't eliminate it. So, wait, I think we had another question back there, and I'm sorry I didn't catch it. Same comment? Mm-hmm. Yeah, so the point that was made, and this is a very good point, is that traditionally SCADA systems have been standalone systems. Okay, so from the supervisory layer on down, they've been standalone, contained within a plant, leveraging physical security, typically, behind a locked door of some sort. And now they're connected to networks, and they've been connected to modems for quite some time as well. So that kind of introduced some additional threats as a result of that. In addition to that, the fact that a lot of these systems have been in place for sometimes 40 years or more, the people who are managing those systems, at that time, nobody thought about security. They just wanted to have the additional functionality that SCADA gives them. And so it was never incorporated. And for the most part, IT, they're left alone until there's a problem. And so IT never really sees them either. So we had talked about Stuxnet. Stuxnet was really interesting. So basically, they have a SCADA system that they were using to control their centrifuges. Centrifuges are used to what's called enrich uranium to make it more pure. And so they were spinning, I think at the time, somewhere around 170 centrifuges. Incidentally, they have about 10 times that number now, unfortunately. And so basically they were controlling it through a SCADA system. They were controlling the RPMs of the systems. And they were getting feedback, which was telling them that everything was in normal operating parameters. So Stuxnet was a multi-threat vector malware product, which is one of the first times we've seen a virus and a worm kind of work together, but that's really how it worked. And what happened was the virus would spread, and actually there was a lot of companies here in the US that got the virus. Fortunately, it was only targeted at very specific PLCs. And basically what it did was it infected a USB drive. All of their systems, all of the SCADA systems that they had, to maintain their security, they air-gapped them. They weren't connected to networks. But what they would do is they would go ahead and anything that needed to be transferred to the system, specifically ladder code, which is the code that they use to, for monitoring and control and programming, it would be transferred through USB drives. And so a USB drive was compromised. It compromised the system itself, went out and basically caused the false readings, spun up the centrifuges to the point where they blew themselves up. This happened in 2010, and there was definitely government. There were government or governments behind it. I won't say who they were, but it destroyed their equipment. And you can see in the bottom photo, Ahmadinejad, who was the president at the time, he wasn't real happy about it when that happened. So another case study. This is something that happened here in the US back almost 10 years ago, about 9 years ago. The Los Angeles traffic control system was run off of SCADA, and they had a system that was in their command center. And at the same time, they had at this particular time, they had a strike, and some of their traffic control engineers were on strike. And so they decided to lock everybody out of the system and basically disable lights at 4 different key intersections. One of them was right north of, I think it was right to the north of LAX. They caused a traffic snarl for 4 days. And so basically, they were able to cause that kind of a problem, and this was a union issue. I'd call it terrorism as well. But the attackers eventually, they relinquished their control, and they put different safeguards in place, access control specifically, in place in order to prevent that from happening again. And these are things you can look up online. These things happened, and they're still, you can still find information on them on the internet. I'm sorry? Yeah. It looked, yeah. I think it was worse than normal. So let's talk about how we would secure an industrial control system. So there is a standard out, the Industrial Control System Society of Automation. It's the Industrial Society of Automation. They have some standards, and they do have a security standard. And it's called ISA 99. And it basically covers some of the main things that we would see in a normal security framework. I'm not going to go over it in any detail, but it's one of those things that you definitely, if you're in the industry, definitely look it up. So one of the things they talk about is security governance, making sure that policies are in place, making sure there's executive sponsorship. One of the problems, and we talked about it earlier, that we have is the fact that you have engineers, industrial control system engineers, who are managing these systems. They have IT, and they don't really talk to each other. And they don't want to talk, well, the industrial control system engineers often don't want to talk to IT. And so you need executive sponsorship in order to make those conversations actually happen. And then also, you know, there needs to be a committee there should be a committee within the organization to govern SCADA security. So one of the things from a security perspective that the standard says is we need to have a threat and vulnerability management program in place. So some of the things, implementing patch management. It's amazing to me, some of those systems, they haven't been patched. I've seen systems, SCADA systems, supervisory systems that were still running on Windows 95. And it hadn't been patched probably since 1997. So that's just, you know, an example of kind of what we're seeing. So implementing patch management, making sure that these systems are patched. So years ago, I used to work for Symantec. One of the things, there was a slide that Symantec had. There was a study that was, well, I think they did the study. But they did the study, and evidently, if all you did was patch systems, you addressed 70% of your problem, 70% of the threat. If you went ahead and you implemented secure configurations, along with patching your systems, that was 95% of the problem. Antivirus and all the other technologies on top of that address the rest of the 5%. So patching is so incredibly important, and that's true for really IT, SCADA, everything. And then, you know, some other best practices, things like disabling services that you don't require on a system. Optimizing security configurations. Testing for vulnerabilities every so often, using something like Tenable Nessus. We talked, you know, just had the presentation from Rob on that. And then implementing an ongoing threat identification and assessment procedure. You know, when there's a new threat that comes out, if it's for a specific operating system, those patches should be applied and the fixes whenever possible. And then implementing logical access control. So, and I'm going to get into some more specific things. So isolating industrial control system networks. defining logical security zones. So, specifically, it's an industrial control system network, very similar to the PCI payment card network. Implementing next generation firewall technology. And I say that, what I mean by next generation firewall technology, I mean firewalls that are going to see the applications as well as the ports and protocols, and then provide some type of a, IPS, intrusion prevention system functionality. Deploying role-based access control. Two-factor authentication is another option. So some very specific, more specific recommendations. Centralized network access to supervisory level industrial control systems using next generation firewall technologies. And we'll get into kind of what an architecture looks like in a second. Provide centralized authentication. So one of the things, let me just give you an example of, I had a conversation with a customer yesterday, and they have about 200 plants where they've got SCADA systems in all the plants, all different manufacturers, Siemens and Wonderware and all these other different manufacturers for SCADA technologies. And they're all controlled in a decentralized manner by plant engineers. And so they're at, one of the things, from a security perspective, how do you control that? I mean, how do you control 200 different plants, 200 different configurations? You have to control access from a centralized location. With the advent of networking and VPNs over the internet and things like that, that's all possible. So then, isolating industrial control system networks using VPNs. So using VPN technology, even across what you might consider secure networks, so within the enterprise. Hardening SCADA management systems, and making sure that they're that these systems are single-purpose systems. So you don't want to allow these systems to be used to surf the internet and then also be a supervisory layer for SCADA, which happens. Monitor supervisory level database activity, just to make sure that databases aren't being manipulated. And then authenticate, and encrypt any dial-up. One of the big issues, or architectural challenges, I think that's probably the best way to put it, with architecting security for SCADA systems is the fact that a lot of times you have PLCs and RTUs specifically that are in remote locations. So think of a pipeline, for example. You might have a company that has an oil pipeline, and somewhere in Oklahoma, they have a valve that controls the flow of oil, one way or another. And there is nothing near that valve. And so they might have a dial-up, where the supervisory layer basically dials up into the RTU and establishes a PPP connection or some dial-up connection. In that case, there really should be some additional security put on that dial-up. And then also physically securing everything from the control layer down to the device layer. So what does that look like? So today, we look at the SCADA architecture, and this was the diagram that I had this on the screen earlier. The way it looks is one of two ways. Either somebody is in a remote location connecting to the supervisory console across corporate network, and it's typically these systems are sitting right on the corporate network, or you might have a situation where somebody is still logging on locally at a plant or at a location where the SCADA, where the industrial control system is deployed. How does, the question now is, what do we do? So to address that issue, what we would want to do is for each location, put a firewall, and in some cases you might end up having to use like a rugged firewall. When I say that, I mean these locations could be oil rigs, they could be out in the middle of nowhere. So that lower firewall is a good example of that. And then controlling access centrally. So if you have 200 locations like our customer has, you would have a situation where you'd have a VPNs from that top firewall to 200 firewalls below. And what you're doing essentially is you are segregating the network. So there is another regulation that strongly recommends segregation of networks. Anybody know what that is? PCI. Yeah, so payment card networks should be segregated in order to reduce the scope of PCI at least. Should be segregated from everything else. And we're doing the same thing with SCADA. This is exactly what we're doing. So some of the technologies you might use, Exedium, they do privileged access management. It gives you the ability to log all access. Palo Alto Networks, they have a next generation firewall platform. These are just some examples. This is not necessarily prescriptive. So at the, for the supervisory layer, for the consoles themselves, for database activity monitoring, Imperva has a product. And for hardening systems, Symantec has a product called Data Center Security. It used to be Control Compliance Suite. It might be necessary to put firewalls right in front of the RTUs as well. That's another, depending on the architecture. And I talked about ruggedized firewalls. Fortinet does have one now. And there are other options out there too. And then lastly, if we have a situation where we have to secure dial-up, there's a company called Communication Devices Incorporated. They've been around forever, since the dawn of IT, it seems like. And they have a product called the CDI UniGuard. And the CDI UniGuard, what it does is it authenticates dial-up connections prior to allowing access. You can use two-factor authentication. You can use other logical access control technologies along with the CDI. And so that's another option. So any questions regarding industrial control system security? SCADA systems. Anybody have any questions about how SCADA works, maybe?
Yeah. So what's the biggest problem you see when people try to put that security in place?
So what are the biggest problems with people trying to put the security I'm recommending? So the biggest problem is the fact that these systems are controlled by industrial control system engineers, and they don't want to do it differently. So it's the political factor. That's the biggest issue. From a technical perspective, this architecture requires network connectivity in order for them to log in through a centralized console. And if that network connectivity breaks, or if there's a problem with that, then you could end up, not allowing them access to their system. So there's got to be a way to address that as well, from a technical perspective. But the biggest problem is really the political problem. And the way to address that, by the way, is to provide an additional functionality for them. So let me give you an example. A lot of these systems, the supervisory consoles, are not backed up. Those databases are not backed up. So if we have a situation where we can offer backups, maybe into a cloud environment, and then offering the access control through that cloud environment as well, that's a way of maybe softening the impact of some of the changes that they're. But this is, it's one of those situations where, there's other ways to apply security, but it could be. They can be challenging if it's still distributed. We have another question.
Well, on your SCADA network control systems, especially where IT is concerned, IT looks at this as, okay, it's another IT environment.
Mm-hmm.
But with the industrial control system, it's actually vastly different than a data network. Because you're dealing with a physical environment, you've actually got physical devices that, if you run, especially with the older PLCs, because most of them were made in the 1970s era,
Yeah.
if you do a scan against them, all manufacturers, even right now, they will tell you, do not run a network scan on a network that has your
I think you bring up a great point. And the one thing I would say is that from an executive, we talked briefly about, executive sponsorship. Really, the point there is, as you had correctly pointed out, you need a partnership. Because the bottom line is, they are different types of systems. And as I said earlier, as in IT, I've been in IT for 20 plus years. And a lot of this technology I was only exposed to recently myself. And so the bottom line is, in IT, we don't really get exposed to it either. And then they don't really know IT as well, so you kind of have to work together. If you don't work together, then you can, as you had said, running a scanner is not a good thing on these environments. You want to make sure that you kind of count the cost before you start assessing those types of vulnerabilities. Using an automated method at least.
Yeah, but isn't that an argument for more for security attackers, or I don't think you said it
That is.
replicating script and start chatting it, and hey, that's a strong argument for security.
Right. That's actually the reason that their IC's environment has taken such a center stage recently, pretty much in the last 3 years more than anything. Within all your news and all your organizations, why Obama has actually issued a lot of different, like I think P27,
Mm-hmm.
which is the president's office directive, that states you must start protecting the industrial control system. Over 85% of America has no clue that the industrial control system is even vulnerable. And the ICS CERT, which is a great organization, if you will contact them, depending on the type of environment that you're in, they can actually send people out to evaluate your own industrial control system network. They will work with you hand in hand and literally identify the problems that you have and some of the best solutions for you. Plus, they can give you all kinds of information on how to secure your own environment and the types of things that you should be doing and you should not be doing, because it is not an IT environment as is typically normally thought of. And so you can actually go through the different options for that.
Yeah. So the one thing I would say is, I think ICA is definitely a good resource there. As I said earlier, the biggest issue, the biggest thing is cooperation. The other thing that's important to understand, and this is the reason why this is such a big deal, is that industrial control systems, they control a large majority of our critical infrastructure. And so all of those areas, areas that were defined by the Department of Homeland Security, oil and gas, power generation, water treatment, food supply manufacturers. As a matter of fact, my brother-in-law used to work for a company here in Dallas that makes a sour cream, and he was an industrial control system engineer. And so, so the bottom line is, it's really everywhere but we don't see it as consumers. We don't see it as the average public person, but it's everywhere when it comes to a critical infrastructure perspective. We have another question. Yeah, so the point was made about NERC SIP, and that's exactly, yeah, I should have mentioned NERC SIP. So NERC, there are some rules that are coming online right now for power generation specifically that will, require a lot of these standards, a lot of these things that we're talking about here. Yeah, so the question was people that are generating their own power, and basically supplying it back to the grid, how that affects, industrial, basically the grid, reliability, I would think. And I think that's something that's been addressed, by the power companies, here in the Dallas area, Encore, or some of the other power companies, power transmission companies at least. But I don't know the answer to that question. That's really outside the scope of this. Pushing power back into it. Oh, we're gonna is there gonna be issues because of that? Yeah. Yeah, so the point there was data systems are controlled by SCADA systems. Your data centers are controlled by SCADA systems. That's absolutely correct, and they can be taken down. And all you have to do is just one control system within the data center. If it's a chiller plant, like you said, here in Texas, when it's in the summertime, you probably don't have 13 minutes in a data center. I mean, you're burning up equipment pretty quick. But not only that, but also it's controlling power and everything else in the data center. Just shut them off, or cause a power surge to blow everything up. Any other comments or questions? Yeah, so that you bring up a good point. For data centers, a best practice, and I do auditing as well. I wrote a book on auditing, or actually wrote part of a book on auditing. But for data centers, one of the things we look for as an auditor is how conspicuous is the signage. We don't want there to be conspicuous signage for the data center. There are large financial institutions that have data centers, here in the Dallas area. You would never know where they are. Yeah, and there's some that have a neon sign on them, usually co-location facilities or those types of.
I've seen several colos that don't have names on them, and you would have no idea that it is. I mean, just a warehouse.
Mm-hmm. Yeah, and that's from a physical perspective. And unfortunately, from a logical perspective, finding these types of systems is easy, typically. Over the internet. Any other questions before we close out? Okay, so I don't see any other questions, so thank you very much. I really do appreciate y'all having me.